Hello student, I am Arnab Das. We are again meet together for continuing our topic for the amplifier. Today is the last class for also amplifier and we are going for discussing the new topic for the class C amplifier. For the class C amplifier, there only some portion of the input signal is used for the amplify. If you consider one as a V in is this one, that time only duration of this is used for getting the output. This is the output waveform which when we got it through the IC. So from this picture we can able to understand that during this short interval the transistor is on, which is used for the designing purpose of class C amplifier. Due to this reason, that is only for short duration of time the transistor is on, transistor power dissipation is so less, or class C amplifier is low for power dissipation. The power dissipation during the on time can be calculated by using this formula, that is PD is equal to IC saturation VC saturation. That means if you multiply between the saturation time collector current and saturation time voltage drop across collector and emitter terminal, that time the power distribution for class C amplifier during the on time can be calculated. So what will be the value for the power dissipation average over the entire cycle? If you consider this one picture where a few number of cycle is used for the input one, and obviously due to the reason of class C amplifier for individual period there is short duration of time will be occur when the transistor is on. So if we consider this is a period for getting the output, that time there this duration is denoted as a off time, this is off time, and this one is denoted as a on time. For the earlier picture it is easy to understand also, where this one is represent the on time duration. To get the average value, that time PD average will be defined as a T on by of TD into of PD on. PD on is this one. If you put this value in this position, that time PD average can be calculated on there. So average over the entire cycle can be calculated by using this formula, that is T on by of T. This is the total time period for the capital T. Saturation current multiplied with the saturation collected to emitter voltage. Because the collector voltage output is not the replica of the input. Look that the output waveform is not the replica of this entire cycle or input signal. So restricted load class C amplifier alone not give the entire input signal as a form of the output. Again, I just repeat that because the collector voltage output is not a replica of the input, The resistively loaded Class C amplifier alone is no value in linear application. So in that particular circuit should be two extra thing by which you can got the output waveform and which is most desirable also. It is therefore necessary to use Class C amplifier with parallel resonance circuit. If you consider this one as a Class C amplifier for the typical one, they're replacing load resistance value or resistor into the form of the tank one. Tank circuit means the combination of capacitor and inductor. So that one can be generate a pulse on there. That is short pulse will be generated on there. So there is continuous pulse generated through that particular tank circuit and output also got and sinusoidal from on there. And here a extra circuit combination is applied. Not only extra, this is desired also. This is the C1 and the RB to make the transistor on for which region it will be identified by getting or by verifying the value for the C1 and the RB. Look at RB, the value is applied one side as a form of minus of VBB, and for that particular reason there this value is used in here. If VBB is known by you and VB is the transistor base emitter voltage, so if you know V of BB and VB from the transistor specification, if you know this one, then you can able to identify for this kind of circuit for which region will be used as the output, that is when the transistor will be on condition. So ultimately the short pulse of the collector current on each cycle of the input initiates and sustains the oscillation of the tank circuit, that means due to that particular tank circuit, so that an output sinusoidal voltage is produced. So our desiredness will be fulfilled if you consider that kind of circuit for an Class C amplifier. So this is a typical figure for the Class C amplifier, and thank you for this class. I think each and everyone can able to understand for the entire amplifier. Obviously the power amplifier are classified into the basic four form. One is the class A, class B, class AB and class C. We discuss within the total entire class that particular individual class, and for the next day we again meet with the another one topic, and then thank you.